Hey guys, we are back with section 11.3 where we will talk about measures of average. We will talk about computing the mean, median, mode, mid-range of data sets, and along with computing the mean of group data and the four measures of average, which we just pretty much discussed. So let's go ahead and get started. Are you an average college student? What does that even mean? According to a variety of sources found on the web, the average college student is 20 years old, lives on campus, and works off campus during the school year. She is female, talks to her parents every day, and comes from a family with an annual income between $50,000 and $100,000. She sleeps 6 hours a night, has $2,700 in credit card debt, and will leave college with $21,000 in total debt. Our goal in section 11.3 will be to understand the different measures of average. In casual terms, average means the most typical case or the center of the distribution. Measures of average include mean, median, mode, and mid-range. Okay, so the mean is pretty much where you add everything up and divide it by how many you see. Okay, that's the average. That's what we usually think of when we hear mean. The mean also is known as the arithmetic average. It's found by adding the values of the data and dividing by the total number of values, which is what I just stated. This is the more complex way of looking at this. But once again, each of these are your data. Then you divide it by how many you have total. And then you come up with your mean. Now, this is an important symbol. You will see this. We read it as X bar, and it is the symbol for mean. Okay, let's go ahead and just jump right on into our examples. You know how Ms. Shannon likes to do it. We always learn better when we see it. So, the total areas in thousands of square miles of the 15 largest states in the United States are provided in the list below. Find the mean area for these 15 states. Do you think it's an accurate reflection of the most typical size? Why or why not? So pull out your calculators, add all of these up, and then you're going to divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Sorry, I'm adding it up too. We should be adding it up together. All right, and then so we got 2,327 divided by 15, which gave us 155.13 repeating. Okay, now remember, this is in thousands of square miles, so we can really turn this into thousands by multiplying by 1,000 to give us a more accurate number. But let's look at what the question is asking. Do you think it's an accurate reflection of the most typical size? Well, it's saying the most typical size is 155. Well, there are only there are only 3 states that are larger than that 155. So no, I don't think it's accurate. No, it's not accurate. Because only 3 states have areas larger, while the other 12 are less than that. Okay, so no, I don't think it's accurate. All right, let's look at the median. The median is always the middle number. The first thing we have to do is always arrange our data in order from least to greatest. Okay, if we end up with the odd number of values, then we have to find the median of the 2 numbers in the middle. Sorry, the mean of the 2 numbers in the middle. So find the median of the land areas provided in example 1. Compare the mean and discuss the differences. Okay, well, if we were to put these numbers in order from least to greatest, which they actually are in order from least to greatest, they're just backwards. To find the median I always start off by marking off about 4 or 5, depending on how many numbers I have. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 1. The median is 104. 104,000 square miles. The mean, remember the mean was 155,000 square miles. Okay, so our median is lower than the mean, and that's probably because the one extremely large state is raising the mean considerably. So our one large state, that 665, is making that mean heavy. Part B says find the mean and median if you throw out Alaska, which is the largest area. So then we're going to do the same thing. The mean actually comes out to be 118,714 when we get rid of Alaska. And then the median is about 101,000. Okay, so as we can see, this is a lot closer. Okay, that's a lot closer than these two were when we had Alaska in there. So that big state was throwing off our numbers. All right. Next, we have the mid-range. We actually found the mid-range of data in section 11.2, I believe it was, when we were trying to find the midpoints of the data. So all we do here is we take the lowest value and the highest value, add them together, and divide by 2. The mid-range is another measure of average. The advantage with the mid-range is that it's very quick and easy to calculate. However, the disadvantage is that it totally ignores most of the data values. Okay, we're not even thinking about what's in the middle. But let's go ahead and give it a whirl. Find the mid-range area for the top 15 largest states from example 1. So once again, we're going to take our largest and our smallest. So that's 665 and 82. And then we're going to divide by 2. 747 divided by 2, which gives us 373.5, which if we multiply by 1,000. So the mid-range was about 373,500 square miles. And the mode. The fourth measure of average is called the mode. The mode is sometimes said to be the most typical case. I say the mode is the one that appears the most. So when we're looking at this data, okay, we can put it in order, and then we can do like a frequency distribution, okay, a frequency table. And just also note that a data set can have more than one mode or no mode at all. When you have more than one mode, it's actually called bimodal. Okay, so if I were to do a frequency distribution, I can write down all the numbers I have, 10, 11, 12, 13, 14, 15. Then I can write down how many times I see that number. 10, I see it once. 11, twice. 12, 1, 2, 3, 4, 5, 6, 7. Okay, so on and so forth. So I will go through and keep seeing how many times do I see these numbers. Then I'll look and see which one appears the most there. So 12 would be my mode because it appears the most in the data set. Okay, here's another example. I can set up another frequency table to figure out which one I see the most. Some of you may have already caught on to, you can just really look at it and see which numbers you see a lot. 8 I see a lot of times. 7 I see a lot of times. So it looks like this one is bimodal. I see a 7 and the 8. They both appear 3 times. So we're going to use that 7 and 8. Let's look at what this data set was about. Some of this stuff is pretty interesting. The number of Atlantic hurricanes for each of the years from 1997 to 2016 is shown in the list. Find the mode and describe what it tells you. Well, we found the mode because I kind of found the mode before I read the question. But what does this tell us? if we are looking at the number of Atlantic hurricanes for each of the years from 1997 to 2016, that's about 20 years. So over 20 years ago, the most common number of Atlantic hurricanes were 7 and 8. So 7 to 8 hurricanes. All right, so we already talked about this being bimodal. The mode is probably most useful when data are classified by groups or categories. In fact, it's the only measure of central tendency that even makes sense when the data values aren't numbers. Okay, for example, in example 6, what we're looking at here, a survey of the junior class at Fiesta State University shows the following number of students majoring in each field. Find the mode. Okay, well, we're not looking for business to show up more than once, or we're not looking for this exact same number to show up once. We're looking for which one has the most information. Okay, in this case, business. We're going to choose business because it's the most typical case. Okay, it's the most typical measure, which would be business with 1,425. All right, the mean of grouped data. Okay, the mean of grouped data. So we now return to the mean, this time in a situation that's a bit more complicated, when we have group data in a frequency distribution. Okay, we've already looked at this information in our last section, and we've actually already classed this, and this is where those numbers came from our classes. So let's just go ahead and rewrite those in our chart. Is that the last one? 9, 10, 15, 19, 20. Okay. All right. So to find the mean of group data, the first thing we need to do is take our classes and label our classes. And then we can also write our frequencies down. I did something wrong here. 3, 8, 16, 13, 7, 2, 1. I'm skipping. 3, 8, 16, 15 to 19, 20 to 24. 25 to 29. I'm like, something's not right. Sorry, guys. May or may not have been a long day. All right, 130 to, well, I'm doing it again. Skipping it again. So 120 to 124, 125 to 129, and 130 to 134. There's the sums. I'll put sums there because I'm like, I know I should have a sums box. Okay, now we're back on track. All right, so now the next thing we have to do is we are going to find the midpoint of each class in the group data. Well, lucky for us, we had already found those midpoints, and we also discovered the trick to it. Remember, finding the midpoint means to add them together and divide by 2. Well, we also just know that's the number that falls in the middle. If you have your old notes, they're on those old notes too, the ones we did in the last video. That midpoint. Next thing we are going to do is we are going to multiply the frequency for each class by the midpoint. So now we're going to multiply the frequency times the midpoint. As you can see, we're using our symbols, frequency and midpoint. When you multiply those, these are the numbers that you should get. Okay, now that we have those parts filled out, we can add up all the products from step 2. So we're going to add these up, and that's where the sums comes in. The sum here is 5715. And we also want the sum of our frequencies, which is 50. Okay? We are going to divide by the sum of all frequencies, which is the total number of data values. So now we could take our 5715 and divide it by 50. And we get 114.3, and we're talking about degrees. So that, we're talking about temperature, so that would be degrees. So that would be our mean of our grouped data. So the steps are pretty much the same. We group our data from what we learned in the last video. We write down our frequencies. We write down our midpoints. And then we multiply them. Okay? Then it just becomes, it's still the average. So now I still have to add all of these up and divide by the number of frequencies that I have. Notice I'm not dividing by 1, 2, 3, 4, 5, 6, 7. I'm not dividing by 7. I'm dividing by the total of those frequencies. Okay? All right. And the last part. Okay, I am not going to read through this. You guys can read through this, but in the last section, I told you guys that a lot of this stuff can be done in Excel. Using a graphing calculator, this is a good page for you to read over and try some things out. Good information, good information. All right, so let's look at this table as the last part of this section that talks about the strengths and the weaknesses of the different measures of average. Okay, I won't sit here and bore you with my reading, but please make sure that in your notes you read over this whole section. All right, once again, you have your discussion questions. Make sure you're reading over them. Make sure you're writing down any questions, comments, or concerns that you have for me so that you can email those over to me and I can